A 16-16. We use the Wilcoxon rank sum test. Say that fast 3 times. Say it fast twice. Anyhow, it gives us some data that we input, right? I did it into columns. I suppose you could do it in rows like they have, but I did it in columns. I got population A and population B. I don't even need to total those or average them or anything like that. What I'm going to do is actually rank all of them. So I've got the rank A and the rank B, okay? And in this case, I have ranked them in an ascending order, okay? So I've ranked them in an ascending order, okay? So all I have to do is, let's delete that. And I come up here and I go, I'll use most recently used because I had that, and I use that rank average one because then you'll see I got a couple here, you know, that were the same, 57, 57, and so it ranked them and it just averaged between the two. Okay, so I'll click OK. So the number in this case for my rank A, I want to rank this number, so I just click on that. My reference though is going to be these 2 columns, and I can just kind of capture both of those. But also I want to hit my F4 on there. I want my dollar signs there, and ascending will be a 0. Okay, order is a number. Rank in the list sorted descending equals 0. Yeah, so I do, if I wanted ascending, I guess I have to put in a number. I had it the opposite last time. I got to put in a number anyhow. So it's ascending. Okay? And then I can just copy this, right? Both directions here. Sorry for the pause, I had to sneeze. So I can copy it kind of both directions. Copy that down. Okay? Then I'm going to total just A. That's all I want to do is total or get a sum of what I have here in A. So I'll pick my auto sum. Okay, and that's that. Boom, there you go. Okay, that is my large W. Okay, and in this case, I have to find out if there's a difference between the samples or no difference between the samples. And I based on the rank sum basis that we're doing, right? And here's my long formula. Okay, well, let's go down and state our hypothesis. First, the null is that there is a difference, or I'm sorry, the alternate is that there is a difference between the samples. The null is that there is no difference between the samples. And so that's an equals, okay? So I'm using two-tailed test, and I got to look up my Z, and let's see, I got to check and see at the 0.05 significance level. So sorry there, I had to pause for a second, but I think I was on the W, so we've done that, and our rank A is going to be our first, our population A is going to be our W, right? So then here's this big long formula, and the math is really simple, but it's just kind of a lengthy formula. At the bottom here, a little bit odd because it should be the square root of the whole thing. Okay, so it'll be the square root of the whole thing. So I kind of set it up, like I often do, I divided the formula up. First, I know my W is here. My N1, or my sample size for the first population, is 8. My sample size for the second population is also 8. Okay, so my N1's 8, my N2 is 8. Your guys, I believe, are 8 and 9. Okay, and my W, 86.5, which I have. Okay, so I kind of did it this way because this is on both the top and the bottom, this N1 plus N2 plus 1. So I did that, and I just simply equal to, right, my N1 plus my N2 plus 1. Okay. Then I multiplied that by N1, okay, because I got to do that before I do my division just because of the order, right? Multiplication is going to come first. I can do the parentheses first, obviously, and then I can do the multiplication first, okay, and then divide by the 2. Actually, I did both in this step, so I said this is equal to my N1 times my, in the parentheses, N1 plus N2 plus, which is my 17, divided by 2. Okay. So that's my N1. Yep, got her. Okay, and then I subtract that from W, right? This should give me the whole top of the equation. This is equal to my W minus this part. So there I get the top of the equation, right? Then the bottom of the equation is equal to N1 times N2 times these things, 17, right? Okay, divided by 12. So I can just put that in there, right? So it's equal to N1 times N2 times that combination there, divided by 12. Hit enter. That all equals 90.66667, but like I said, I got to take the square root of that, and then I will have the bottom of the equation. So it's just equal to the square root. You guys know how to do the square root, so okay, it comes up to that 9 points. So I just got to divide the top part by the bottom part, so it's equal to, this will be my Z, top part, divided by my bottom part. Looks like it's going to be about 2, huh? 1.94. Okay, again, I stated my hypothesis was that, my alternate hypothesis was that, and I looked up the Z's, it was at 0.5, or 0.05, I'm sorry. So if I look up the Z's again, then I've got to go to 97.5, right there, 1.96, and that would be on the bottom as well, a minus 1.96, because remember I am a two-sided, right, two-tailed. Okay, so I reject it if it's less than, or I reject it if it's greater than. Yeah, it's right in between, isn't it? Yeah. So HO is not rejected. There is no difference then between the samples that I have. There you have 16-16.